In perilymphatic fistula, what happens is that there is a fistula between the inner ear to the middle ear throughout the usually oval round window. Now, what it causes perilymphatic fistula is CSF can get out, but also it causes pneumolabyrinth, namely air in the labyrinth, in the vestibule, in the cochlea. And now look at this MRI sequence on this heavy T2 sequence, which is a cyst sequence, so it's a heavy T2 sequence. You can see the normal CSF in white, and here you can see the inner ear with its cochlea part and vestibule part, and here are the semicircular canals, and this is the internal acoustic canal getting into the midbrain and the temporomandibular and the cerebropointine angle where the vestibulocochlear and facial nerve go through. And here on the left side of anatomical left side, in this side, there is much more hypointense signal. This is because there is air in here, in the vestibule and in the cochlea, and the air is black, hypointense on this heavy T2 cis sequence, because remember that air doesn't have any protons, so no hydrogen protons in it. So there is no MRI signal in any sequence, including a T2 heavy sequence like this. So you can see that there is much more hypointense signal. Instead of the vestibule, we should see the semicircular canals and the cochlea. This is what can be seen as air in the vestibule and in the inner ear. And this is because, in this case, this is because of perilymphatic fistula that let air get inside the inner ear. So this is the case, a very nice one, air in the inner ear as a result of perilymphatic fistula. Thank you very much. You can also read it right over here. Cyst sequence MRI of a patient with perilymphatic fistula showing significant air in the vestibule and the anterior crus of the horizontal canal, as well as the second turn of the cochlea, as we can see on these arrows. Thank you very much. Thank you for the resource for this, and thank you all, and that's it.